A cone, a right cylinder, and a hemisphere stand on equal bases and have the same height. Their volumes are in the ratio. So in this question we have given a cone, a cylinder, and a hemisphere which are having equal bases. Equal bases means they have the same radius and also they have the same height. So first of all we draw the given solids. There is a cone, as in the question it is given that all the solids have the same heights, so we draw a line parallel which is passing through the vertex and parallel to the base. Now there is a right circular cylinder, and there is a hemisphere. Let's say the radius of a cone is r1 and the height is h1, and the radius of the cylinder is r2 and the height is h2, and the radius of the hemisphere, let's say r3, and the height is h3. As in the question it is given that the base are equal, it means their radius are equal, that is r1 equals to r2 equals to r3, let's say equals to r, and their height is also the same, that is h1 is equals to h2 is equals to h3, let's say it is equals to h. But in a hemisphere the height is equals to the radius, so we can say that r3 is equals to h3. So we can also say that r3 which is equals to r and h3 which is equals to h, and r3 and h3 are equal, so we can say that r is equals to h. We can say that r equals to h. Now we finding the volumes of these three solids. The volume of the cone to the volume of cylinder to the volume of hemisphere. As we know, the volume of the cone is 1 upon 3 pi r square h, that is r1 square h1 is 2. The volume of the cylinder is pi r square h, and the volume of the hemisphere is 2 upon 3 pi r cube. As r1, r2, r3, h1, h2, h3 all are equals to r, or you can say h, we put instead of r1 and h1 we put r here, so we are getting r cube. Instead of r2 and s2 we put r, so we are getting pi r cube. Again here for r3 we put r here, so we are getting r cube. From these three ratios pi r cube is common, so we can cancel out pi r cube, and pi r cube. So we are getting the ratio 1 by 3 is to 1 is to 2 by 3. Now multiplying this ratio by 3, we getting 1 is to 3 is to 2. So our required answer is 1 is to 3 is to 2. So according to option B is correct. Now we move to the next question. If the volume of the solid is 40,656 centimeter cubic, the diameter of the base is 42 centimeter and the height of the cylinder is 20 centimeter. Find the slant height of the conical portion. So as in the question, we have given a solid in which there is a cylindrical portion in which there is a cylindrical portion surmounted by a cone, and the diameter of the base is 42 centimeter. The diameter of the base, it means we can say the radius, let's say the radius of the cylindrical portion, that is R1 is equals to diameter divided by 2, that is 21 centimeter, and the height of the cylindrical portion, let h1 is 20 centimeter. Now the base and the base of the cone and the base of the cylindrical portion are same, so their radius are also same. Let the radius of the cone R2 is also equals to 21 centimeter, and we have to find the slant height of the cone. Now we are assuming that the height of the cone is h2 and the slant height be L2. Now the volume of the solid is equals to the volume of cylinder plus volume of the conical portion. So we separately find the volume of cylinder and the volume of the cone. First of all, we find the volume of the cylinder, which is equals to pi r square h. We can say pi r2 square pi r1 square into h1. The value of pi is 22 upon 7. The value of r1 is 21 square into h1, which is 20. So while calculating this, we getting the value as 27,720 centimeter cubic. Now we find the volume of cone. The volume of the cone is given as 1 upon 3 pi r2 square into h2. 1 upon 3, the value of pi is 22 upon 7. The r2, that is 21 square into h2. Now while calculating this, we get the value of volume of cone in form of h2, which comes to be 462 h2 centimeter cubic. As we know, the volume of the solid is equals to volume of cylinder plus volume of cone. In this question, the volume of the solid is given as 40,656 centimeter cubic, and the volume of the cylinder, we have already found that it is 27,720 plus the volume of the cone, which is 462 h2. Now 462 h2 is equals to 40,656 minus 27,720, which comes to be 12,936. So h2 is equals to 12,936 divided by 462, which comes to be 28 centimeter. Now in the cone we find the h2, that is the height of the cone, but we have to find the slant height. The slant height L2 is equals to under root of r2 square plus h2 square. The value of radius is 21 square. The value of h2 we already calculated, that is 28 square. The 21 square is 441. The value of 28 square is 784, which comes to be 1225. The under root of 1225 is 35. So the value of L2 is 35 centimeter. So according to option B is correct. Now we have a pen stand which is in the shape of a cuboid. Which is in the shape of a cuboid, which is having length L, breadth B, and height H, and which is having three conical holes, which is having three conical holes, which are having same radius, let's say capital R, and the height as capital H. All these three conicals have the same radius and the same height. Now we try to find the volume of this pen stand and also the surface area of this pen stand. First of all, we find the volume of this pen stand. As we seen that the volume of the pen stand is equals to the volume of the cuboid. As we are making the three holes, so we have to subtract the volume of these three portions, three conical holes. So the volume of the cuboid is, volume of the pen stand is volume of cuboid minus 3 times the volume of cone. So the volume of the cuboid is L into B into H minus 3 times the volume of cone is 1 upon 3 pi capital R square capital H. We can cancel 3 by 3. So we are getting LBH minus pi capital R square capital H. This should be the volume of this pen stand. Now we try to find the total surface area of this pen stand. So for this total surface area, so in this solid or in pen stand, we seen that the total surface area is equals to the total surface area of cuboid, total surface area of cuboid. As we see, the upper portion is look like a rectangle which is having three holes in it of radius R. So this portion, so the remaining portion, so from the cuboid we have to subtract these three holes. So the area of these three holes is 3 pi R square. Now while making the conical portion, we get a new area which is the curved surface area of the cone. So we are making three holes, so we getting the three curved surface area of the cone, that is 3 times the curved surface area of the cone. So the total surface area of the solid is twice LB plus BH plus HL minus 3 pi R square plus 3 times the curved surface area of the cone, that is pi capital R and capital L. The value of capital L can be calculated as capital R square plus capital H square. So we can get the total surface area is twice LB plus BH plus HL minus 3 pi R square. Sorry, this is capital R square, this is also a capital R square plus 3 pi capital R. For L we substitute under root of R square plus H square.